Good morning. I hope you're ready for the second lesson on graphing trig functions. This is the other trig functions today, section 4.6. And we're going to do all the other ones, everything else. We'll do them as quick as possible, pretty much. But there are some little details that we do need to talk about. So, assume you're writing this title, section 4.6, graphing the other trig functions. And first thing we do need to remember is that the sine and cosecant are reciprocals, and that the cosine and secant are reciprocals. That helps us when we need to graph the y equals cosecant x and y equals secant x. So we're going to use their reciprocal function to help us know what we should, where the graph should be. So here we are. There's the question, what does it mean to the graph? First thing we want to see, I'm going to put on here in the light colored green, maybe as a dotted line, y equals sine of x. So you see the little green dots are already on here for sine. Here is where the sine function would be. But y equals cosecant x is the reciprocal of these values. So let's see. What is the reciprocal of 1? Here's the point 1 at pi over 2. What's the reciprocal of 1? 1 is the reciprocal of 1, so that point I just graphed in red belongs to the cosecant function. All right, let's go here to the minimum value at 3 pi over 2 at negative 1. What's the reciprocal of negative 1? The reciprocal of negative 1 is also itself negative 1, so that point belongs to the cosecant. But now, the other interesting points that we dealt with yesterday.
Jill Manning, you have a telephone call in the main office.
Sorry about that. Are the intercepts. Now, the value at 0 for the sine is 0. What's the reciprocal of 0? Okay, just think that through. The reciprocal of 0 is undefined. 0 does not have a reciprocal. So, please, at 0, you're going to put in an asymptote because it's undefined. There will be no points at that point. Here at pi, it's also 0. The reciprocal of 0 is undefined, so at pi, there are no values for cosecant. So it's an asymptote. And at 2 pi, it's 0 again, and the reciprocal of that is undefined. So we have a third, the picture we have here, a third asymptote. And here's the deal. If the point over here, let's go way over here, is 1/2, the reciprocal of that is 2. So if I think about the point right here at 1/2, the reciprocal of that is 2, so there's 2. Here's another 1/2, so there's going to be another 2 there. Going closer, how about a third is going to be 3, so that would be up here, and on the same little hump on the other side there is the 3. So you see the shape is, it's not a parabola, but it looks like one. It has a similar shape to a parabola. And in this second half, where we're down in the negatives, same thing. If I have negative 1/2, the reciprocal of that is negative 2. So I get a point at negative 2 here and there. And at negative 1/3, I would get a point at negative 3 and negative 3. So there's how we are seeing how these points are generated, just to find out what the shape looks like. So there's what the shape looks like. It's little separate horseshoes. Yes, one's up, the next one's down. In the next section, it would be one up and then down again. So hopefully you remember that. Moving on. Here's a secant, and the secant is the reciprocal of what? The cosine. So we're going to think about this graph. That graph is going to give us the important places. We notice it has a 2 there, so the amplitude is 2. The period doesn't change, so it's 2 pi. And we see it doesn't have any shifts in it. So let's graph the cosine with an amplitude of 2. Starts here, minimum at pi, maximum again at 2 pi. Intercepts in the middle. So now, as with a dotted line, we'll graph the cosine. Again, now we think of the secant. It's the reciprocal of what we're looking at. So here's a 0. What's the reciprocal of a 0? An asymptote. Anywhere you have an intercept, it turns into an asymptote. Here at the 3 pi over 2, again it's 0, so the reciprocal would be an asymptote. And the fine, which on the graph is an asymptote. Then at this maximum point up here at 0, we're going to turn a branch going up. We'll just get half of that. And then here at the minimum point, we have a branch turned downward. And here is the maximum again, and I get a branch coming towards the left. Towards the asymptote. There is our secant. Okay? Everybody remembering how to do these? So, let's do a big one with some stuff going on here. And it does say, notice it has some parameters here. It says from negative pi to pi. So that's how much of the graph we're going to fill up. You notice there's a lot more graph on this. I got some negatives. But you only need to if it gives you those parameters, that's all you have to do. So you don't have to worry about filling up the graph. But if it doesn't give you parameters, I would really like you to fill up the graph. Okay, this is cosecant, so which function do I compare this to? It's the sine. Alright, so the amplitude is, for the sine, is the 2. Pen's not writing, has to change. The period is, there's the 2 in front of that, so it's 2 pi over 2, which is pi. And we see there's no shifts, so those are zeros. Wow. Pen's not happy. So, now, this is sine. Do you remember the little mnemonic device, the little funny word that we remembered for sine? I, me. So there's our mnemonic device to get this in here right. And we're going from pi, so from 0 to pi, and our amplitude is 2. So intercept at the beginning and end, intercept in the middle, a maximum first quarter, a minimum third quarter. And so there is our graph. That's a delayed reaction. I was finished and there was still problems here. Okay, there is our gauge, okay? Now, let's put in our asymptotes. We do want to go all the way to negative pi, so you might want to bring these over here to the negative side and put in this part. So now we can follow along. I hope you can hear the sound there. Alright, the intercepts are asymptotes. So here's an asymptote at negative pi, asymptote at negative pi over 2. Asymptote on the origin. Through the origin on the y-axis. Pi over 2, and at pi. So now we're going to fill in all our little branches. And these maximums and minimums are points of our function. There we go. Please don't cross the asymptote. I've had students who would give me this and they cross the asymptote. Don't forget what asymptotes are. We did have some that crossed horizontal asymptotes, but not vertical. No functions that we have cross vertical asymptotes. Alright, there is the 2 cosecant 2x. So see, the amplitude grew to 2, and the period got smaller, so we got more within a smaller, distance. We have more repetitions. Okay? Keeping up? I mean, if you need to pause the video because somebody's not through, just please have someone do that. Just remind you that you can always do that. So, or if you can rewind, you drag the little thing across the bottom, I believe, to rewind to something if you have to. All right, one more of these. Here's a secant. Which function is this the reciprocal of? It's the reciprocal of the cosine. So, what's our mnemonic device for the cosine? Anybody? Alright. Try this again. The mnemonic device is me. Ma'am. Boy, that's not being nice. Alright. So for cosine, this time it asks us to go from negative pi, that's why this is moving, because I put it all together and so we can move it over, and get a 3 pi on here. I wonder if the pen will. Yay! So there's our 3 pi. So what's between there? Pi over 2. Now, our mnemonic device is me, mem, and we need some values for our little list here. Don't forget to put this list on there, even for secant, cosecant, and the tan and cotan. Our amplitude is 3, but there's a trick. Problem with this one is it goes down. Okay? Then there's no change to the period, so we have it's 2 pi. And we see it has no, that was a 0, but it didn't draw it. Okay. Starting at 0, we have a maximum of 3, but is down. So we're starting here at 2 pi. We also have that minimum of 3. And halfway we have the opposite of that, so it's going to be a maximum here. And we can move another group, since I've got to go beyond that, I'll just continue the pattern. Alright, so I've got a point at negative pi and a point down there at 3 pi. Halfway between here we have our intercepts. So if that's an intercept, I do like this drawn in here as a dotted line. Some teachers don't require it, some students think it's not necessary. It's nice to have that dotted in there. Now we're going to put in the asymptotes. Change colors for the asymptotes. Through those intercepts, you have an asymptote. Okay? So we got to get them all through here. Let's see how fast this will do it. So the rest of this, just putting the graph part, is the easy part. Branch here, one at the bottom, top. Let me remind you on the graphs that you're going to do for me, please don't change the scales. Draw what fits on there and stop. If it's really little and you have lots of them, you just have lots of them. If it's really wide and big, we didn't change the scale on this, we just added a little more. Do not change the scale, please. Okay? Alright. There is y equals negative 3 secant x, the blue graph. Any questions? Oh, I'm looking at that and I see that it says from negative, well, we did the same, the distance of x was. Alright. Now, let's move on to our other two functions. tangent and cotangent. And I know you're wondering why these two guys are here, Goofy and our wrestler friend over there, but let's see. Graphing y equals tangent of x and y equals cotangent of x. So now we're going to look at our final two. And they have lots of similarities, but they do have a little bit of differences. The tangent is said, and this is just, I don't know if any other teacher says this, but I talk about it as it's right-handed. So if you will raise your right hand and lower your left hand in the same kind of position, and then look at what if you were to mirror that down on your paper. Okay? So essentially, if you mirror that and you look at Goofy, he's doing that. Now, if you were Goofy, he's raising his left hand. Now, I'm sorry, it's just that mirror thing. So, you know, he is looking like you would look as you look down at your paper. So here's what I'm telling you. The shape of the tangent is the shape of this arm going up to that arm. It didn't show up very well, so maybe do better in another color. Could you see it better in red? Okay, there is the shape of the tangent. Now if the tangent has a negative, it flips. So what's pointing up is down and down is up. But this is your normal tangent. It's right-handed. So look again, raise your right hand. Look as if it were laying on the paper that direction, raising its right hand. Okay, this is the tangent. Now, our wrestler friend over there, yes, I know, if you were him, it's his right hand up. But would you please raise your left hand and look as if it was to be laid down on the paper. Okay, mirror what you have on your paper, and it holds left hand up. And the cotangent is said to be left-handed, so it is shaped like that. Now it means that it curves at the top, it goes straight up and out slightly. But there's the shape as left-handed. Okay, and this is the cotangent. So that's what I mean when you hear me say tangent is right-handed, cotangent is left-handed. The right side of the tangent is headed up. The left side of cotangent is headed up. Raise your left hand. So, the other thing you see, the little I's and the A's. I stands for intercept, as it did with the me, mem, and I, me thing. A stands for asymptote. So, we've got intercept, asymptote, intercept in one period of the tangent. And the cotangent is AIA. Asymptote starts it, intercept in the middle, asymptote finishes it. Now, as we do a few in just a minute, we're only going to do one of each, you'll see what I mean. Now, here is a big difference in the tangent and cotangent. The period is only pi over b. Different. Remember, previously for the other four, it's 2 pi over b. It's just pi over b. Gotta remember that little change. So here's your little memorizing information if you did not remember anything about tangent and cotangent. So let's go to the next page and let's graph one of these. It says from negative pi to 3 pi. I think I have some extra line down here, so I'll move this down so we can get 3 pi on the page, maybe. Okay. Put a couple of marks here for that will be 3 pi way at the edge. Okay. Here we have y equals 2 tangent x over 2. X over 2. Please copy that carefully. Get your graph ready. I'll try to pause just a minute while you get that written down. We're going from negative pi to 3 pi. Look and tell me what the value of A is. Oh, I need to tell you something. There is a value of A in secant, cosecant, tangent, cotangent, but it's not an amplitude. Okay? Amplitude, as amplitude, the absolute value of A, is your maximum value. Does a secant or a cosecant have a maximum value? Think about it. Does a tangent or cotangent have a maximum value? The answer to all those questions is no, because you have arrows that point up. and up and up and up and up. And so, the range is going to be positive infinity, well, negative infinity to positive infinity, because you got arrows going both ways. So you got to just be careful to not call it the amplitude, but it is an A value. The A has a value, and it is functional in what you're at. So the value of A in this equation is 2. The period. Ooh, what is B? What is the coefficient of X in that equation? You see a number in front of X? There's a number under X. What if you had to make that a coefficient? What would it turn out to be? I hope you're saying 1/2. So B is a half. So let's see, we need pi over 1/2. What does that turn out to be? Pi times the reciprocal of a half. Reciprocal of a half is 2. Pi times 2 is 2 pi. Okay? Are you with me? Yeah, I know, that doesn't look like 2 pi. There's no horizontal or vertical shift, but you can shift. If it's vertical, you're going to move the left and right, the beginning and the end of your first period, left or right, whichever direction, the same distance. And if a vertical shift, you move your midline up or down, whatever distance, just like you did yesterday. Okay? And you will have some of those that you actually have to do, but we're just not going to focus on that part. Okay. To begin graphing, this is tangent. So I need to remember that tangent is I and AI. That means at 0, at the y-axis, there is an intercept. So there's going to be a point of this graph there. Now what's my period? 2 pi. So I go all the way down to 2 pi, that's the end of that, and there's another intercept. And then right smack in the middle of those two, I get what? What does A stand for? An asymptote. So I'm going to draw in an asymptote at pi. Now, we need to go all the way to 3 pi. So that same distance on the other side of 2 pi, where's the next asymptote? It will be at 3 pi. And going the other way, where's the next asymptote on the other side and the negative side? It's at negative pi. Okay. So I hope you see, if you step back and look, I got 2 intercepts on the board, and that's all. So we're going to end up drawing 2 branches of this, and that's it. They're going to be really big. But here's the use of that 2. Here's our intercept, and halfway between the intercept and the asymptote is the value of that A. So this point will be a point on this tangent. Now, why did I put it there? For one thing, I'm remembering that tangent is right-handed, so on the right side of this intercept, it goes up. Okay, let's go to the other intercept, and halfway between that next intercept and that following asymptote toward the right, halfway I'm going to go up to, again, that's to the right. That's the right hand up. But if the right hand's up, the left hand is down, so we're going to that negative value. So to the left over here, I have a point at negative pi over 2. This comes down to, and to the left of this intercept, I come down to, and that helps me get the shape. So are you ready to draw the whole thing? It starts down here, goes through that point, and turns up, goes through that one. Boy, not being friendly. There's one branch, and I get to draw another branch because it needs. So here we go. And don't forget to turn up. Okay, you do need to change the curvature after the intercept, okay? And that could have been a little prettier right through here, but it's fine. As long as you don't draw straight lines, okay, we're good. So do you see what I mean when I say that tangent's right-handed? This right hand is raised, this left hand is lower. All right, moving on, last one. Guess what it is? Yeah, I know you mean. Cotangent. This time we're only going from negative pi to positive pi. So we don't have to draw some more graphs. We're just going to get that much of it. But we have some things going on over there, so let's see. There's a 3 cotangent 2x. Get that copied down. Get you another graph ready. This is cotangent, so it's left-handed, and the form of it is AIA. AIA. Asymptote, intercept in the middle, ends with an asymptote. Okay. What is the value of A in this equation? I'm sure you said 3. But the period, the formula is pi over B. What's B? 2. So it's pi over 2. That's the period. All right, and no shifts, so we'll leave those blank. So at the y-axis, where everything begins at 0, the origin, look up here, and we see that it starts with an asymptote. So right through the y-axis is an asymptote. Then, where does this period end? Oh, it ends at pi over 2. That's not very far away. There's another asymptote. There's where it ends. What does that mean? That means every half a pi, you have another asymptote. So here at pi, I get an asymptote. That's as far as they asked me to go to the right, so let's go to the left and get the asymptotes. Where's the next one to the left? Negative pi over 2. And another pi over 2 to the left, I'm at negative pi. So there are our asymptotes. What does the I stand for? Intercept. So right in the middle, halfway between the two asymptotes, we get an intercept. So every one of these midpoints is an intercept. And then every quarter, okay, halfway between the intercept and the asymptote, split that in half, you go up to 3 or down to 3, but we got to be sure we use the right hand. Cotangent is left-handed. So to the left of this intercept in red, we're going up to 3. There. To the left of that intercept, we're going up to 3. Here. To the left, we're going up to 3. And to the left, we're going up to 3. So what are we going on the right side? We go down to 3 each time. So you can see those. After you get the pattern going, it's pretty easy to get the next little branch. Good. And now is the fun part. You get to just draw them. So I think I'm going to start at the bottom. So you see the left part of this branch is up and the right part is down. It's left-handed. It's holding up its left hand. Okay? And so since it asked us to get the interval from negative pi to positive pi, we got to keep drawing these till we get all the ones that fill in the space. Good? Okay, here's the deal. If you have any questions about these as you go, then ask your neighbor. Again, this lesson will be online. You can go watch it. I'm sure you just want to see this again. But if you still have some part of it that you missed, or you didn't copy the notes and you realize later, oops, I do need that written down, they are there. So you can go look for them. Your assignment, are we ready to turn the page? Here it is. You need to get a piece of graph paper, whatever the graph paper is for today. I think it's the 8 one. And I think one piece of 8, because every one of those in blue up there is not a graph. Some of those just ask you for things. And then you do have one little multiple choice thing where you're either choosing the graph or the equation for the graph one way or the other. Okay? All right. If you have questions, ask an adult in the room or ask a smart friend. All right. I'll see you guys Monday, and I hope you have a great weekend.